So next topic is coefficient of variation. So I would say coefficient of variation is a number which tells you how much risky is the investment. That means, let's say there are two investment options A and B. If coefficient of variation of A is 5, if coefficient of variation of B is 7, this shows B is more risky investment and you should expect more returns from this. And A is less risky investment. You should expect, you know, of course, you should expect satisfactory returns from A, but those returns cannot be more than B. Why? Because the variability, the volatility, the risk involved in investment A is less compared to B. Okay, that is what is the importance of coefficient of variation. That is the interpretation from coefficient of variation. So it helps you to compare two securities, the risk involved in investment, risk involved in the investments. Okay, when you are taking or considering two investments or two investment options, you can, this number of coefficient of variation can tell you which is more risky. Accordingly, you can expect your returns. Okay, so the formula for coefficient of variation is standard deviation of a asset divided by the average returns from that asset. This is the standard deviation of returns, and then there is a average return, okay, which is denoted with X bar. Now they say lower coefficient of variation is better. See, this is from the perspective of someone who wants to take less risk. This is not from the perspective of a person who wants to take more risk. So any point of time, don't just put this as a remembrance, okay, that I just always remember this lower coefficient of variation is good. No, see, there are many people in the world who have different kind of risk appetite or different kind of approach towards risk. One is a risk seeker, one is a risk averse. Risk seeker will always want to take more risk. Risk averse would always want to take less risk, but he wants high returns with less risk. And risk neutral is someone who is okay with whatever risk, is okay with high risk or low risk, does not matter. Doesn't matter. Someone comes to your home as a guest, you offer tea and coffee to them, and there will be some guests who are very biased. They say that I'm a teetotaler, so he will always ask you for a tea. Someone says that I just want to consume coffee because I like coffee, so he will be asking you coffee. But there are some people who is okay with either tea or coffee because they say either of them gives me the same kind of satisfaction. Those are neutral people, okay, who are okay with high risk or low risk, doesn't matter. So now you can understand, you yourself can consider in this example what kind of a person you are, whether you want to take higher risk or you want to take lower risk. Now there are some people who always tell you, you just invest your money in stock market, you do intraday trading, you'll get so and so returns. They are the people who take maximum risk because intraday trading is risky. There are some people who tell you to go for SIP. Okay, see, it doesn't matter. Blindly no one will suggest you. People will see your requirement, people will see your income, earning capacity, people will see your like aims, people will see your ambition in the future, what you want, what goals you have. Accordingly they will be giving you a suggestion, okay. But generally people have nature, and once nature is to take less risk, once nature is to take high risk, once nature is okay, fine. So don't always draw conclusions when you see statements. Coefficient of a lower coefficient of variation, a lower coefficient of variation is better. That is only from the perspective of risk averse people who want to take less risk but want higher returns. Okay. So there is a question given. Can you calculate this? You have the standard deviations for T-bills. You have the standard deviation for Standard and Poor. You can see the variability. This is very, very highly volatile and risky. This is very less risky. T-bills are the least risky investment in the world. It is United States government security. Never the US government has defaulted on their security. Never ever till now. From the date when they started this, started issuing the treasury bills to people, and they started, arranging funds for their development projects. Okay. So of course this will be least risky. Hence the standard deviation is less. High risky, the standard deviation will be more, and accordingly you see that the coefficient of variation for this is less. It should be less. It is a natural fact. and then you can draw a conclusion that this is less risky and you'll get less returns. This is more risky, you'll get more returns. Fine. Now comes the target downside deviation. See, when I explained you about standard deviation, I was explaining always with the help of a normal distribution curve. Okay, this is a normal distribution curve. What I always explain you, standard deviation, if you expect that the returns from a particular investment option which you are holding should be 10% on an average, and if that can give you 12% at times or 8%, that means there is a standard deviation of 2% here. Okay, see, no one in the world, is worried about higher returns. You are in fact happy. You always want higher returns, but you're always worried about when you set a target that you should get this much on an average and you're getting less. You are worried about this, and that you want to see the target downside deviation. That means you want to check the downside risk of an investment. Okay, upside you are happy, but downside you are not happy. You don't want a return less than your expectation. Is it right? So for that you should check the target downside deviation or target semi deviation. There's a formula for that, whereby the B here is nothing but the target return which you have fixed. X bar is your observation of the returns, and you see the deviation between them, and you just try to target. You just try to find out the standard deviation in this case. Okay, so the returns are here, like your data is here from the previous question, it has been taken, and they are saying you to fix two targets, either 22% and 24%. Given the target what you have said, what is your downside risk or target downside deviation, which you eagerly want to know? That will show you how much you are away from your targets. Okay, how much variability is there in the target, like in achieving your targets. The more the variability, the more the risk. Okay, so here you can see one measure of downside risk is target downside deviation, which is also known as target semi deviation. Calculating target downside deviation is similar to calculating standard deviation. Yes, of course, not something you're doing new. There you're taking your expected return. Here you're taking your target return. But in this case, we choose a target value against which we measure each outcome and only include deviations from the target value in our calculation. So the difference between the target downside deviation and the normal standard deviation, in normal standard deviation, you take deviations of all the observation from your mean. But here you only take the downside. You see the outcome which is less than your target. Okay. See, but in this case, we choose target value against which to measure each outcome and only include deviations from the target value in our calculation if the outcomes are below that target. So when you calculate at the end, so here in this formula, there is one more very important element. Observation is when less than the target returns. You only take those deviations when you only to calculate your target downside deviation. So with this you clearly understand, right? I'll explain you. See, calculate the target downside deviation based on data in the preceding examples for a target return equal to mean 22% and target return equal to 24%. So now I'm taking the deviations here. The deviations are in front of you. Now your target here was 22%. What are the returns here which are less than 22? One is this and one is this. Only these two values are relevant for me. So I have taken the values what are given. I have squared them, added and divided by n minus 1. So my target standard deviation is target downside deviation is 5.10. Here also I have set a target of 24%. So I'll take only the values which are less than 24. So that target deviation only I want. So less than 24 is what? 23, 20 and 12. So these values I will be taking, and I'll be taking a deviation of this standard deviation. You'll get this. What do you understand? Which is more volatile? See, standard deviation is high in case of this, more volatility, more risky. Okay, more deviation you can see from your target, less deviation you see from your target. Okay, more stable. Please go to this question. We'll move forward. If done, shall I move forward? Okay. Let's come to the next topic, skewness, kurtosis, and correlation. See, I'll explain you this one. See, this is a normal distribution. Skewness you can understand very properly with the changes in the shape of the normal distribution curve. See, this is a bell-shaped curve whereby you fix your you fix your average returns as 10%, or let's say the class. Let's say you have joined a college or you have joined a company and they ask you to come at 8 a.m. every day. So just a second, excuse me, just a second. Yeah. So if 8 a.m. is the time you need to go to office on daily basis, okay. So this is on an average in 365 days. We expect this time for you to come to, uh, start your work in your office. This is the time you have to enter the gates. Okay, enter the gate, and this is thorough symmetry. That means 50% of data lies here, 50% of data lies here, and here mean is equal to median is equal to mode. Now, let's say skewness we have discussed right now about skewness, right? Most of the times you don't come at 8 a.m. You always come at 8:30 or 8:45. So your symmetry will go in this way because most of your data lies in the right tail. So this is what your 8 a.m. was. And you see there is a skewness in the data. The curve has got skewed here because lot of data lies in the extreme tail or outliers you see because you never come on time. 8:45 a.m., 8:30 a.m. always you see yourself in this area. So this is right skewed, and here I already told you in the first class mean gets distorted because of extreme observations, and you see mean at the right side. Median doesn't get impacted, and mode is here. Okay, so this is a right skewed curve. Okay. Now there's also left skewed. So here what happens, maximum times you are coming 7:45, 7:30 a.m. That means always before time, not required. Before time is also not required. Who asked to come? And after time also you should not come. No one asked to do that also. We want you to come at 8 a.m. almost every day in 365 days. So I see in 365 days, a 300 data you are in this zone, a 300 days data you are in this zone here. So this is left skewed. Okay. So here mean again comes here, median in the middle, and mode in the extreme end here. Okay, because they are not distorted or not impacted or affected. This is more impacted or affected. This is right skewed, this is left skewed. Okay, now we discussed about the skewness. Coming to the next concept, that is kurtosis and correlation. So kurtosis also tells you about the shape of the normal distribution curve, whether the shape of the normal distribution curve is more peaked or the shape of the normal distribution curve is flatter. Okay, so more peaked is nothing but most of the data lies near to mean. Let's say this is the normal distribution curve, and if I tell that your curve is more of this kind, this is peaked. Okay, this is your average. Okay, and your curve what I have spoken to you right now is nothing but leptocurtic. This is the shape. Lot of data 8 a.m. That means you are always coming at 8 a.m. and 2 minutes or 7:58 okay a.m. So this is what you always maintain, and lot of data is concentrated near this, so it becomes peaked. Okay, in 365 days, almost 350 days you see yourself in this. But let's say if you're this is the normal distribution curve, and lot of times you see yourself in extreme zones like here and here in tail. That means in 300 days you always come at either 8:40 a.m., either 7:30 a.m. Okay, no, never you come on time. You come always in this too. So most of the data is concentrated in the tail. Hence, the particular normal distribution curve becomes more and more flatter, and because your tail has become fatter, and this is platycardic. And if your kurtosis is like exactly following the normal distribution, just some here and there, some point here, I would say rather than taking 8 2, you take 8 10. Okay, a lot of data is like 750, but here very close. That means you always come at, excuse me, excuse me. So like I like to put it in this way, 8 a.m. is what you are supposed to, come to the office, and 8, to 8 a.m. and 2 minutes and or 7:58 a.m. is what you always come. So you see yourself very near to the average, very near. That is mesocurtic. Okay. So as here you can see what kurtosis does. I will show you the definition as well. Rightly I explained you, but if you see the statement, you will try to understand that. So here it is positively skewed, negatively skewed, positive skewed, symmetrical. Then you have negatively skewed. Okay. And I will tell you one thing. First moment shows the shape. Okay. And also tells you about the answers for each and every data. Second moment, third moment, fourth moment. First moment is mean, whereby sigma x by n is your formula, and you always usually get answers either in positive values or negative values. Second moment is your standard deviation or variance, whereby x sigma x minus x bar the whole square divided by n. Okay, n minus 1 for sample. And this is what you get positive, you get your values in plus or minus either, because when you make a standard deviation, when you make a normal distribution, you see the data either at right side or left side. That shows the standard deviation. Third moment is your skewness, which is sigma x minus x bar the whole cube divided by s cube, or sigma or n cube x minus x bar by n. Okay, okay, and here I would put the whole cube, but fine, don't do that. This is the formula exactly. You can put n cube for your convenience if you are more habituated to that. This is the third moment, and the answer which you always get is either plus or minus, again because cube, right? When you see the answers for cube, either it will be positive value or negative value. Fourth moment is your kurtosis. I'll just put it here, kurtosis and skewness for this. Sorry, there's a space constraint here. X minus x bar the whole power 4 by n power 4, and this will also be either positive or no plus or minus, sorry. Okay, like the standard deviation. And kurtosis is the measure of degree to which a distribution is more or less peaked than a normal distribution. That's what we saw how a normal distribution curve is behaving, how the shape of the normal distribution curve is. Either it is very much peaked, or it is flat, or it is exactly going with normal distribution. Okay. And we have to learn the concept of excess kurtosis also. What is excess kurtosis? A distribution is said to exhibit excess kurtosis if it has either more or less kurtosis than normal distribution. See, normal distribution, if I take here, your standard normal distribution has a mean of 0, 1 standard deviation, 2 standard deviation, 3 standard deviation. See, you can fit any data into a normal distribution curve with an average of any number, but this is the standard. Okay. So your entire data is this. So what happens? What is excess kurtosis? Excess kurtosis is what? Uh, you know, uh, uh, that means your normal distribution curve is getting peaked or flatter. Okay. So then what is that? See, a distribution is said to exhibit excess kurtosis if it has either more or less kurtosis than normal distribution. We saw peaked data or flatter data. So we see excess kurtosis in those cases. The computed kurtosis for all normal distribution is 3. So you should understand, any point of time, whatever kurtosis you compute for a normal distribution, it should be 3. Anything more than 3 shows the excess kurtosis. If the computation you have done for a data and you have computed the kurtosis of the data, if it comes 5, then the excess kurtosis is 2. If it comes 7, excess kurtosis is 4. Okay. And for a normal distribution, this which I have explained you, for this the excess for this the kurtosis is equal to 0, because this is a normal distribution. When you see peaked curve, when you see flatter curve, then you see some kurtosis there. Okay, this is the normal one. So the normal distribution has a excess kurtosis of 0. a leptokurtic distribution has excess kurtosis greater than 0, because leptokurtic goes peaked up. So it is, I already told you, for a normal distribution, excess kurtosis is 0. For leptokurtic distribution, the excess kurtosis will be more than 0, because it will be, bulging out of the normal distribution curve. Okay. So for platykurtic, it is inside this normal distribution curve. Okay. So for this, the excess kurtosis is less than 0. Okay. See, more kurtosis, more skewness, more volatility, more risk. You want more returns. Understood? Because most of the data lies in the outliers. Most of the data, it is very much away from the mean. Okay. So you don't see, you see the extremities. Either you see very near, either you see very much away. So here kurtosis is a critical in risk management setting. Most research and distribution of security returns has shown that returns are normally distributed. Actual securities return tend to exhibit both skewness and kurtosis. And here you can see the conclusion point. In general, greater excess kurtosis and more negative skew in returns distribution indicate excess risk or increased risk. Why? Because we are speaking about excess kurtosis. Excess kurtosis is nothing but whatever you wanted the distribution to be, that is normal, it is not that. It is either very much bulged out, or it is very much like either the outliers you see in the data, okay, which is at the tail. Okay, but when you see mesokurtic, it is very much with the normal distribution. There you see less kurtosis. Okay, so in case of excess kurtosis, very high excess kurtosis, like 3 is what is acceptable limit. Okay, but if it is 7, 8, 9, so you see more and more risk. Okay, and if at all more and more negatively skewed, you see more risk. Fine. So this is the formula for kurtosis, which I have already written here as fourth moment. Now coming to the next concept, scatter plots. What does scatter plots show? Scatter plots show in which direction, okay, when you plot a graph, you see the data, going towards. For example, if I take sales, if I take price and supply. Give me a second. See price and supply, and you when you plot a graph, you always see this is quantity supplied, this is price. Okay, so 0. As price is increasing from 1 rupee to 2 rupee to 3 rupee to 4 rupee to 5 rupees, you see quantity supplied increase to 10 units to 20 units to 30 units to 40 units to 50 units, and you see a positive relationship between them. You see all the points lying on one particular line. Okay, this is the line of best fit. Okay, and you see the scatter plot showing that all the points are lying on this line, and it shows a positive relationship between price and supply. Okay, and this is a perfect positive correlation. What we see, I will come to the concept called correlation, don't worry. Okay, I will explain you what is that concept also. Basically, if I want to say, correlation shows the strength of the relationship between two variables. Okay, now I will like here the variables what I have used is supply and price. Okay, because supply is also changing every point of time and price is also changing every point of time. So these are the variables what I have used. So strength of the relationship between two variables is, if I say, see, correlation is something which is in the scale of -1 to +1 with 0 in between. +1 means perfect positive correlation. -1 means perfect negative correlation. 0 means zero correlation. Okay, this is the data in front of you. Fine. And here perfect positive correlation means what? Perfect positive correlation means so what does the perfect positive correlation means? The perfect positive correlation means if the price increases by 1 rupee, here you can see from the price was 1 rupee or $1, you took 10 units, you supplied 10 units. When the price has just increased from $1 to $2, you are supplying 20 units, more 10 units. That means when the price increases by $1, there is 100% chance that the quantity supplied will increase by 10 units. That's it. That's it. Or else if you take two stocks, let's say I am linking a stock with Standard and Poor. That means I have taken the stock of Tesla company and I am linking that stock with S&P, Standard and Poor. Let's say, see, I don't know about the US market that much. I don't study it. I know some companies' names. Tesla started with as a startup. Whether they have an IPO, their stocks are available. Maybe their stocks are available and they may be registered. Okay, this is a stock market. So let's say, see, small example to prove. I can give you very good information about Indian companies like, let's say, HDFC Bank. Okay, and we have Bombay Stock Exchange. You know that, BSE. So I am linking the performance of HDFC with BSE. If the BSE goes up, it's an index, right? HDFC will also go up. But I have to check the strength of the relationship between them. That means if BSE goes up, that can only be known with the help of correlation coefficient. Let's say I calculated the correlation coefficient of HDFC's returns and BSE's returns. There's a way to find out. We will go to that. Okay. We will also discuss that, and that correlation coefficient came out to be 0.70 plus positive. So that means if BSE stock index will go up, there is a 70% chance that SDFC stock will also go up. As simple as that. This is not perfect positive correlation. This is partial correlation. Okay. Perfect positive is either 100% change. Okay. Either positive way or negative way. What is a negative correlation? You should understand the concept once again. What can be the best example for negative correlation? Demand and price. So here we have quantity demand. Here we have price. So I will take 10 units, 20 units, 30 units, 40 units, 50 units. So here when the price is 1 rupee, $1, the quantity demand is $50. Price is $2, $40, $3, $30, $4, $20, $5, $10. You see, when the price is increasing, the demand is decreasing. It is negative relationship the price and quantity demand has, and it's a perfect negative correlation. That means if the price goes up, 100% chance, okay, price goes up by $1, 100% chance that quantity demand will decrease by 10 units. Okay, or same case, if I get 0 minus 1 as correlation, if the BSC will fall, if the BSC will increase, okay, 100% chance that SDFC will decrease because negative relationship. If this increases, that has to decrease. Okay, or if BSC, if it is negative 0 minus 0.70, if BSC stocks, if BSC index will go up, 70% chances SDFC stock will go down. That is negative correlation. Okay, and if I show a data in this way, do you think there is any correlation here? Zero correlation. I am not seeing any direction this has. Okay, and sometimes it is not necessary that there should be a linear relationship. Linear relationship means straight line. Exact for this change, 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 this change. That means for 1 rupee increase in price, 10 units decrease in quantity demand. That means from 50 to 40, from 40 to 30. Okay, so you may sometimes get the data, and if you frame or plot a graph, you will get a curve that shows a curvy linear relationship, not a linear relationship. That is also possible. You will be learning some concept in fixed income like duration and convexity. So that point of time, duration shows a linear relationship. Okay, in what I will tell you, don't worry, the price of the security and the interest rates. And convexity shows curvy linear relationship. I'll tell you and explain what that is when I'll be dealing with that concept. Now, coming to the next concept, I'll see how much time it would take because I need one more session to wind up this chapter. Covariance. See, to explain you correlation, not a big deal, but I want to explain you the covariance and correlation accordingly. Just a second. Okay, so we will do one thing. Tomorrow we will take up the covariance concept and we will finish this topic. Okay, because you as you see only one formula there, but it is not the matter of one formula. Only 10% of the concept is left over. I have to explain you the covariance with a good example. I will come with my own data, and then I have to explain you what is the problem with covariance and why there was a need created for correlation. All this would take some time because you should properly learn the same concept you will be learning again in portfolio management. Now coming to the next topic, what we are going to take up, it is going to be the probability. Probability trees and conditional expectations. Very simple concept. Only Bayes theorem is what you need to understand in this. So we will do that Bayes theorem also. Bayes formula. I'll explain you what is Bayes theorem, Bayes formula. Okay, that we can wind up as this is done, we can finish that chapter by tomorrow itself. Okay. Because covariance and correlation will take a long time. So we'll do it afresh. Done. Done. This will be done by tomorrow and this will also be done. So 4 topics done. We'll enter into portfolio mathematics. By this weekend, my target is to finish the till 5 chapters and also big data. Okay, small topic, just a small topic it is. We can finish that also. Fine. What do you say? Shall we take right now or shall we take tomorrow? All in a fresh time. Yes. Akila, what do you say?
As you
Tarun, what do
wish,
you
sir.
say? No, 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 not as per me. I'm asking from your perspective also. If you say right now, I'll take it right now. If you say tomorrow, I'll take tomorrow. No problem. What do you say? Akila, what are you saying?
We can do it now. If I am okay, I don't. Let's
Okay,
start
okay.
the
We'll
other.
do, we'll do. No problem. We'll do. Fine. That's okay. So we'll take up a small data and understand what is covariance. Okay. Okay. So here we will take up a data, small data. So let's say you want to make a portfolio. Portfolio is nothing but you want to, take 2 stocks in one single portfolio. See, this will consume a lot of time. That's what I'm saying. More. Okay, fine. Let's say I always tell you, don't put all the eggs in one basket, right? My that means I'm telling you that you go for portfolio form of investment. Don't put all the eggs in one basket means what? If you just put all 1 dozen eggs in this particular basket and if you're walking and someone hits you, this entire basket will fall and you'll lose the entire eggs in this. All will damage. So what remedy you have to save yourself from these kind of losses? You can take 2 baskets and fill either baskets with 6 eggs, half dozen. And when you walk and someone hits this basket, you still have one more basket and you can at home come and cook your egg, right? So the same thing goes with portfolio form of investment. Instead of putting the entire money in X company stock, you try to consider some Y company also. Okay. So that if you put 50, if you put some money in this and some money in this, suppose you have 100 rupees, you put 50 in this, 50 in this. This is giving you a loss of, let's say 3%. This is giving you a gain of 14%. And if I see net in net, I make a gain of 11%. That is only possible because I have made a portfolio here. Okay. That is portfolio form of investment. But what this is also called as diversification. Diversification in your investment. Okay. But why there is a need for you learning the concept of covariance? Whenever you create a portfolio and take 2 stocks like X and Y, you have to see in what direction they are, moving. Okay. Whether X is following Y, whether Y is following X. Okay. That means if X is increasing in value, Y's stock is also increasing. If X stock is going down, Y stock is also going down. If X stock is going up, Y stock is going down. These 3 things you have to see. Okay, that you can check with the help of covariance. The covariance number gives you the idea. Okay, about that. So let's see the formula for covariance first. Yeah. The formula is like, this is sample covariance. Okay. X minus X bar sigma into Y minus Y bar whole divided by n minus 1. So I wanted to give you a live data. See, I wanted to give you a live data and explain this. So like, this is the formula. When you get an answer for this formula, let's say you get a number, the covariance number is 5. That will only tell you about the direction in which the stocks are moving. That means X and Y, right? That shows if X goes up, Y will also go up. Because the number is positive, there is a positive relationship between these two. If X goes down, Y will also go down. Okay. That is what is positive relationship. If you get a number -3, that means if X goes up, Y will go down. Definitely. This is negative relationship what they have. So this particular number can only tell you about the direction in which the stocks will move, but it cannot tell you about one thing, the strength of the relationship. That means if X will go up, what are the chances of Y going down? Excuse me, just a second. तुम बोले ना वो सीएम है यूएसए का, बोले एक बार। हम्म। ओके, क्योंकि क्या है ना, अपने को एक 9 मंथ्स So I only know about the direction, but I don't know about the strength of the relationship. The strength of the relationship means what? If X would increase, what percent chances are that Y will also increase? Until and unless you don't know the strength of the relationship between two stocks which you are taking to form or make a portfolio of investment, you would not be confident. And one more thing I would like to not be confident about your portfolio. Why? Because you should know the behavior of the stocks when you take them together. Okay. And one more point I would like to say, if you are making a portfolio, okay, you should pick the stocks which have negative correlation between them. Then only you can expect a very high diversification benefits. Okay. What happens is, if at all you take two stocks, that means I told you right now, see, if I have two shops, one is in Jubilee Hills and one is in Kukatpalli. Okay. And the relationship what they should have is negative correlation. What is negative correlation? If one particular shop is giving profits, another should give me a loss. Then only I can take maximum benefits. Why? I'll tell you. If this shop is giving me 1 lakh rupees profit and this is giving me 50,000 loss. So net in net, I still have on an average 25,000 profits. Why? 1 lakh minus 50,000 is 50,000 divided by 2, 25,000. So on an average, this is giving me 25,000 benefit and this is giving me 25,000 benefit. That is only possible because of the negative relationship correlation what they have. But let's say if this is giving me 1 lakh profit and this is also giving me 1 lakh profit, very happy, right? 2 lakhs profit you have. If this is giving me 1 lakh loss, that will also give me 1 lakh loss. So then you have minus 2 lakh loss. So if at all there is a positive relationship, what is happening is when there is a profit, there is very high profit. When there's loss, there's a very high loss. But if there is a negative relationship, whatever the case is, I may get a profit of 25 on an average, but I will definitely get a profit. The probability or chance of me making a loss will be minimized to a very high extent. That means very less chances of I going into losses. The that is what is portfolio way of investment. Okay, that is not putting the entire money in one full stock, putting it into two stocks and seeing that they should have a negative correlation between them. Okay, relationship between them. Now here we discussed about covariance, right? The number only tells us about the direction in which they are moving, but it does not tell us about the strength of the relationship. That can only be known with the help of correlation. Okay, so what they have done for that is, listen, this is the formula for covariance, right? The covariance number can be anything. It can be number which is 1 lakh. It can be a number which is 3. It can be a number which is 5. It can be a number which is minus 10 lakhs. Whatever answer you get, but you're not able to decide the strength of the relationship. So to know the strength of the relationship, what they have done is they have normalized this covariance number. That means they have tried to bring this covariance number in a particular scale of -1 and +1. How did they do that? How did they normalize this? They took the covariance and they divided with the standard deviation of each stocks which are a participant of this portfolio. So covariance of XY stocks divided by standard deviation of X stock and standard deviation of Y stock. With this, what has happened is they normalized this covariance number and they bought that in this scale. With this, they got correlation, that is rho xy, Greek letter rho xy. Okay, so now covariance is also, so when you normalize the covariance with its by dividing the covariance with their standard deviation. You put them in a scale and then the resultant answer what you get is the correlation. Okay. Or else you can write down covariance as nothing but correlation of xy into standard deviation of x into standard deviation of y, cross multiplication. And when you get the correlation, you know the strength of the relationship because it is always between -1 and +1. Okay. So this is all the concept. We will do a question here. This is a question. So there is a variance of returns on stock A. There is a variance of returns on stock B, and there is a covariance. You have to take the variance, find out the standard deviation by making a square root. You get the standard deviation. You get the standard deviation of second one by doing the square root because variance is given. You get this one. When you have the standard deviations of both and you have the covariance also given to you in the question, 0.0058, you get the correlation 0.9842. Okay, this is touching almost 1. It shows there is a perfect positive relationship and very strong positive relationship between stock A and stock B. If stock A increases, 100% chance stock B will also increase or decrease. Okay. So we will stop here. Tomorrow we will continue. Some part is there. Again, it seems to be a small paragraph, but no, there is an explanation for this. A few minutes of explanation and we'll immediately go into the probability chapter. Okay. Thank you so much.